we talked a little bit about wastewater characteristics and some of the effects that discharges of wastewater have on uh, a water environment. Today, we're going to talk a little bit about how we regulate those wastewater discharges. The regulation, as we know it today, kind of started with the Clean Water Act. The Clean Water Act is a piece of federal legislation that was established and enacted in 1972. It's sometimes called CWA, the abbreviation for Clean Water Act, and sometimes people call it PL 92-500 because it was a law that was passed by the 92nd Congress, and it was the 500th bill in that Congress. So it's the basis of federal water treatment regulation today. So one of the things that the Clean Water Act does is allows states to take over the regulation of water pollution in each state. And that's called primacy. Primacy is when a state takes over a piece of federal legislation and enforces that legislation themselves. So the Clean Water Act allows individual states to take over the program and to administer it themselves. Now, why might that be beneficial to a state, you might ask? And basically, the thought is that individual states could better regulate water within that state because every state's a little bit different. And the conditions in every state are different than the conditions in other states. And if the EPA were doing this regulation, then the EPA would enforce one piece of legislation all over the country, and everybody would have to conform to the same legislation. If an individual state takes over the program, they can establish laws that basically have, an equivalent effect, but they can do that in a way that helps the individual state and conforms to the conditions of the individual state. Also, when a state takes primacy, the federal government gives them funds to be able to support the program. So, for example, in Utah, we have the Department of Environmental Quality, and within that department is the Division of Water Quality. The Division of Water Quality, the personnel there and the programs that they administer there are basically paid for by federal funds that come from the Clean Water Act. Because the state is doing the job that the federal government would have done, the federal government would have spent so much money doing it, so they turn that money over to the individual states, and the states then are allowed to administer the program themselves. It also gives the states the opportunity to work with individual dischargers to make things, I guess, work out better for that discharger in the state. So, how does the Clean Water Act actually control the discharge of wastewater? Well, the first way that that's done is with what's called the National Pollutant Discharge Elimination System. So basically what that is, the NPDES program, is it requires everyone that's discharging wastewater to a navigable body of water in the United States to have a permit to do that. You have to file for a permit to be able to discharge wastewater to a surface water. So if a state's received primacy and is administrating the Clean Water Act on their own, they establish their own kind of permit. So for example, in Utah, we have UPDES permits, or Utah Pollutant Discharge Elimination System permits. So in these permits, the individual states establish how much wastewater can be discharged, in other words, a volume or a flow rate, and they also establish the amount of pollutant that can be discharged by each person who receives a permit. So they might say, for example, the city of Provo, their wastewater discharge, their permit, their UPDES permit, requires them to discharge no more than 10 milligrams per liter of BOD based on samples that are taken in a month. So a monthly average of those samples has to be 10 milligrams per liter or less. Okay, so every discharge then has to have a permit. And so the individual who wants to discharge the wastewater has to apply for a permit from the state. And then that permit tells the discharger what volume or what quantity of wastewater they can discharge, and also tells each of the permitters what amount of pollutant can be in this wastewater they discharge. Oftentimes that limit is set as a concentration, like the BOD standard that I just mentioned. Sometimes, though, the standard is just a total mass, and they say you can discharge so many pounds of BOD in a day. And it doesn't matter what the concentrations are, but in a day you can only discharge so much. So that's the main way that the discharges are controlled. Now, the Clean Water Act also established a construction grant program, which later turned into a revolving loan program. So initially in 1972, when the law was passed, the law said if a municipality is going to build a wastewater treatment plant, then the federal government will pay up to 80% of the cost of constructing that plant. So they were really trying to control water pollution at that time. And so the federal government was willing to help pay for a substantial amount of the facilities that were built in local communities. So the Clean Water Act, like many other pieces of federal legislation, has to be reauthorized every once in a while. In one of the more recent authorizations of the Clean Water Act, the construction grant program was eliminated. So the federal government no longer pays directly for building wastewater treatment plants. But what they did establish is what's called a revolving loan fund, and they call it different things in different states, but basically it's a system of low interest loans that the state can establish, so that if you're going to build a wastewater treatment plant, you can apply for a low interest loan to do so. Now, right now, that's not a huge advantage because interest rates are pretty low right now. But when this was first established, interest rates for construction were, double digits, 10, 11, 12% in some cases. And the revolving loan allowed municipalities to get loans maybe at 2 or 3%. So they saved a significant amount of money by getting these revolving loans. And that's kind of where the legislation is today. Individual places can get revolving loans to build treatment plants. In the state of Utah, there's a water quality control board that's established in the water pollution division there. And if somebody wants to get a revolving loan and build a wastewater treatment plant, they have to go to a board, a water quality control board, that's established by the state. The governor appoints the people there, and they apply for these permits, and the board then decides if that permit's going to be granted of the two. Okay, so here's an example of a typical NPDES permit. This one's for Hailey, Idaho, and you can see that in their case, that 30/30 standard is what they have to meet as far as the BOD goes. Then they have a standard for E. coli, for fecal coliforms. They have a standard for nitrogen, ammonia nitrogen, for total phosphorus and for total Kildall nitrogen. So basically, they have to meet all of these standards. Okay, so there's their permit. Every place that's discharging wastewater to a surface water has a similar permit that they have to meet. So how are these permits enforced? Okay, well, let's talk a little bit about that. So every month, everybody who has a permit has to submit what's called a discharge monitoring report, or a DMR. So basically, in addition to setting limits for BOD and all those kinds of things in your permit, the permit's also going to say how often you have to sample for the particular pollutant that you're discharging. So for example, they may say you have to measure the BOD 3 times every week, or maybe you have to measure it every day. Maybe you have to measure it 2 times a day. whatever. The permit's going to say how often you have to monitor. So in your discharge monitoring report, you're going to list all the sampling you did and the results of all that sampling. And then you're going to say, did you meet the requirements of your permit or not? Okay, now this seems kind of interesting because basically what you're saying is the person who has the most benefit of violating this permit is the one who is reporting how well they did. So that's a real conflict of interest, right? If you're a little bit over, you might say, hey, I'm going to fudge this a little bit because I want to stay within my permit. Because if you're out of compliance with this permit, you're going to have to pay fines. You know, that's where the rubber meets the road. If you're not in compliance with your permit, you're going to have to pay fines. And those fines right now are up to $25,000 per day per permit violation. So if I'm doing really bad at my treatment plant, I might be violating several of the parameters of my permit. So maybe the BOD is over, the suspended solids is over, the total coliform's over, whatever. Each one of those individual permits you could be fined $25,000 every day you're in violation. So if you think about that, if I have to meet a 30-day average and I don't meet that 30-day average, that might means I was in violation 30 times in that month, right? So if it's a monthly average or 31, whatever the month is, then you multiply that by $25,000 a day and it adds up really fast. Okay, so this is a real problem. Okay, but it keeps people in line. Now you might ask, well, why wouldn't people lie on their discharge monitoring report so that we know so they don't have to pay these fines? Well, the reason for that is if you're caught fudging these numbers in one way or another, it's a criminal offense, and you could end up going to jail. So, and I've seen that happen in several cases. I worked on some treatment plants in Hawaii. We'll talk a little bit more about that later, but and in Hawaii one time, there were a group of operators who at a treatment plant were bypassing the plant at night. So in other words, when they thought nobody was looking, they just turned the treatment plant off and let the water go right out into the ocean. And then they reported on their discharge monitoring report that everything was good and that they reported values that were just erroneous. Well, they got caught, and as it ends up, they had a criminal trial, and several operators had to go to jail for a significant period of time. It was over a year, I can't remember. So you don't want that to happen. Okay. Now the other thing that happens is every once in a while, unannounced and randomly, the state's going to come to you and say, hey, we want to have half of that sample you took for the BOD today because we're going to measure it, and then you measure it, and then you're going to compare your results. And so that way you can kind of see, have they been doing this appropriately or not? So you're going to split samples once in a while. But still, there's some motivation for people to lie on these things. But basically, you don't want to do that because of the consequences are pretty severe. Okay, so the person who turns this discharge monitoring report in is called the person with direct responsible charge, or the DRC. And this person, the DRC, is the one that's ultimately responsible for that report. In some, industrial companies where they have their own wastewater that they treat, they sometimes laughingly they'll call this the DRC. They'll call him the designated felon, right? Because if he's going to lie, he's the one who's going to go to jail about it. And there's some pressure sometimes on these guys to lie about that kind of thing. Okay, so again, as we mentioned, the ultimate way that the permit's enforced is through a series of fines, and we just talked about what those fines were, and it can be pretty significant. Now, again, I mentioned that I worked on a project in Hawaii, and I was asked by the church to go to Laie and work on a treatment plant there that was out of compliance. And in this little treatment plant, tiny little treatment plant for the city of Laie, Laie has like less than 15,000 people who live there. And when I got there, we found that the fines that they had built up there were over $4 million. It was like $4.5 million. So it adds up pretty quick, and it can be very significant. But a big corporation like Dow Chemical or something, it's like, hey, no big deal. We can pay $25,000 a day. It's not a big deal to us. So, there's some pluses and minuses to all this kind of thing. Now, one of the things that also I haven't put on the slide here, but it's really important as far as enforcement goes, is the Clean Water Act allows concerned citizens to sue people over the Clean Water Act. So if you think somebody's in violation of the Clean Water Act, you can file a lawsuit against them. And it's pretty easy to prove if they have or have not. All you have to do is go look at their discharge monitoring report, and if they're out of compliance, it's on that report. So if I go to the state and say, hey, I want to see the DMR for Provo for the last 5 years, right? And they have to give it to me. It's public information. I can look it over and see if they're out of compliance. And if they are, then I can sue them. And so it's called a citizen's action suit. And basically, you're going to win that suit, right? Because they reported they were out of compliance. So there's a bunch of environmental groups right now that will go around to states and request the DMRs from different places and monitor them and just make sure people are doing what they're supposed to do. And if they're not, then they sue them. Okay, that's what happened to this little plant in Laie. That an environmental group, it was called the Sierra Club Legal Defense Fund, went to the state, and they had heard that the plant there in Laie was out of compliance. They went to the state and said, hey, we want to see the DMRs for the Laie plant. So they got them, and sure enough, the plant was out of compliance, and so they sued them. Okay, now, as it ends up, the Sierra Club Legal Defense Fund didn't have really a standing. They weren't local citizens that were affected by this discharge. So they found a local environmental group and said, hey, these guys are out of compliance. We could sue them, but we need somebody local, to file the lawsuit for, kind of thing. And so this local environmental group stepped up, and a lawsuit was filed in their behalf by the Sierra Club Legal Defense Fund. And basically, there wasn't much that anybody could do. The plant was out of compliance, and so it was, and they reported it themselves, and so we can't say, hey, no, we weren't. They were. So but what happened in this particular case is what happens most often when a citizen's action suit is filed. And that is the two parties that are involved in the suit, in this case, this local environmental group and the church, because the church owned the wastewater treatment plant, they got together and said, hey, we know we're out of compliance. Here's what we're willing to do to make up for it. And they iron out an agreement between the two parties, and it's called a consent decree. So most of these suits are settled by a consent decree. And in the consent decree, basically, the church promised, okay, we'll do this. And the environmental group said, okay, we're good with that. So they go to court and they say, hey, we've ironed this out ourselves. These are the actions that we want to take to resolve this lawsuit. And then the judge has to agree to that, okay? And in this case, they did. So in this particular case in Hawaii, that the church said, we'll build a new wastewater treatment plant, and we'll pay some money into a fund that you can establish a new environmental group here. And anyway, so they didn't have to pay the fines, but they did have to pay some money and build a new wastewater treatment plant that was up to doing the job. And that's why I went over there to help with building this new treatment plant. Okay, so that's typically, very commonly, how these lawsuits are settled. Now, where do fines go if fines are levied and you have to pay fines? Well, they go to the general fund of either the state or the federal government. So it's not directly going to help water pollution problems, it's just going to the general fund. And that's why environmental groups like to get involved, because they want the money that goes from the fines to go directly to solving these environmental problems that were caused. And I think that makes some sense, but basically, the other thing that happens is the parties who file the lawsuits, they don't get money, right? They have to either, fines have to be paid to the government, or money can be spent on these other projects, like I said. So oftentimes what they'll do is the parties that are in violation will say, okay, we'll buy a whole bunch of land that we'll put in a trust, and it can be used for some environmental, something or other, and stuff like that. But they cannot just say, okay, we'll pay these people who sued us a couple $1,000,000, because no money's going to change hands like that. The Clean Water Act doesn't allow that. Okay, but it will allow them to do other projects and that kind of thing. So if I sue, I'm not going to come out ahead monetarily. Now, who does come out ahead, and it seems like they always do, is the attorneys. Because if they win that lawsuit, then you have to pay their attorney's fees. So whatever happens, it seems like, the attorneys always win. But that's kind of the way that happens. Okay, so that's kind of the Clean Water Act and how it's enforced. And so every time I'm going to discharge wastewater, I have to get a permit, and then I have to live by that permit. So, for example, when Geneva Steel existed out in Vineyard, they had to get a permit to discharge wastewater. And they discharged wastewater to Utah Lake, and they had a permit to do that. And every once in a while, the state would come back and say, okay, we're going to change the permit in this way or another. Now, remember back when we talked about conventional versus non-conventional pollutants, okay? So when these permits were first established, they basically were established just based on these conventional pollutants. The EPA kind of said, hey, this is a huge job regulating wastewater. And so what we're going to do is we're going to, first of all, we're going to set up permits for the conventional pollutants in all these places and try to get a handle on that. So they were working really hard on that. And one of the environmental groups looked at that and said, hey, that's great, but the Clean Water Act doesn't say you just need to clean up conventional pollutants. It says all water pollution. And so they filed a lawsuit, these environmental groups, and the EPA lost. Actually, what happened was they had a consent decree, and the EPA said, okay, so in addition to these conventional pollutants, we're going to also focus on this group of things we call priority pollutants. And there was 129 of them, and the list was based on, the EPA did a survey of things that were discharged the most quantity, and also that had did the most harm. So based on kind of the harm factor versus the quantity, they decided which of these pollutants needed to be controlled most, and then they started to establish limits for those pollutants also. So they're called the priority pollutants. So you notice on that Haley, Idaho one, in addition to the conventional pollutants, they had a standard for phosphorus and for nitrogen and some other things that aren't really conventional pollutants. Okay, so that's really typical. And if they're controlling the waste, say, for example, from a petroleum processing plant, well, they're going to have all sorts of exotic waste that are on the priority pollutant list. So they're going to have an NPDES permit that's quite complex and might have a big long list of things that they have limits for that are on this list of priority pollutants. Okay, so I think that covers most of what we want to talk about as far as the Clean Water Act goes. It's much more complicated than that, obviously, but as I've mentioned before, we have a graduate level class where we talk about wastewater treatment at 651, and we go into a lot more detail about that in 651. And then we have even a second graduate level class that talks about wastewater treatment that is 654. It's like advanced water treatment processes and wastewater treatment processes, and we talk about it even in more detail there. Okay, so let's talk about wastewater treatment. So first of all, let's look at a typical wastewater treatment plant. So this is kind of a typical treatment plant, the kind of thing, this is a treatment plant that would meet the secondary treatment standards. Okay, so in this particular case, the water's coming in, the raw wastewater comes in, it goes first to a pump station where the water's raised up. See, Wastewater flows to the treatment plants by gravity, and so as it travels through the community, first of all, we're going to locate the treatment plant at kind of the lowest point in elevation in the community, and then we're going to try to get all the wastewater to flow there without having to pump it. We want it to just flow downhill there. So sewer lines are set at a grade that allows the wastewater to flow without it being pumped. So it's open channel flow in a pipe. And every once in a while we're going to have to pump it, but we don't want to pump it very much because of the constituents that are in the wastewater make it difficult to pump. But what that means is because it's flowing by gravity, the sewer line is getting deeper and deeper and deeper underground. So by the time it gets to the treatment plant, in most cases, the water is maybe 10 or 12 feet below the ground level. So the first thing we do at the treatment plant oftentimes is pump the water up to that surface elevation so that it can flow through the wastewater treatment plant. And you can see in this diagram the pump station there. Okay, now treatment is divided up into different categories, and you can see in the dotted lines on these boxes it talks about these different treatment categories. So the first box there, as the flow goes, is called preliminary and primary treatment. So basically primary treatment is the primary settling basin there, and everything before that we call preliminary treatment, or oftentimes the workers at the plant just call it the headworks of the plant, or pre-treatment. So preliminary, pre-treatment, headworks, that's these first couple of steps. So the first thing that often happens is we pump. Now, one of the things that this particular diagram does not show, and this is really important, one of the first things that you want to do with the wastewater is measure the flow rate. Okay, so usually as soon as the water comes in, we measure the flow rate. So that's kind of the first step in the headworks at the plant, or the preliminary treatment. Then we lift it up, and you can see there, then there's a grit chamber. The idea of a grit chamber is to remove things that very easily settle out of the waste that aren't going to be easily biologically degradable. So it's going to include things like sand and gravel and shards of glass and seeds from fruit, eggshells, things that are really dense, have a high density, and will just settle out really quickly. And they're not going to biologically degrade very well. Coffee grounds are another thing that's really commonly, it settles out in a grit chamber. So we settle that easily removed stuff first. Then the water goes to a preliminary settling basin, and in this case, the water is going to stay in there in about a half an hour. We're going to settle as much stuff as we can settle out in that half an hour. But the stuff we settle out here is biologically degradable. It's stuff that has a high BOD, but is easy to settle out. Okay, so the stuff that settles out settles to the bottom of that basin. We call it sludge. It's a solid material. It will mix with water, and really, it's only going to be about 2 or 3% solids as it ends up, but it's a lot of material that we can remove there. So after preliminary treatment, then it's going into what we call secondary treatment. So primary treatment is if it receives preliminary treatment, then the primary settling, we call that primary treatment. And after that is secondary treatment. So secondary treatment, remember we define secondary treatment according to the EPA, but in this case, secondary treatment just means a certain kind of treatment technology is being employed. In this case, it's generally in secondary treatment, we have some kind of a biological process. Okay, so we're going to use microorganisms to degrade the waste. So the engineer's job is to engineer an environment so that we can grow the right kind of microorganisms to get rid of the waste that comes into this process. Now we've settled the easily removed stuff out. We got rid of the non-biodegradable stuff in the grit chamber. So now what's left in that waste should be readily degradable by microorganisms that are present. Remember we talked about how there's a lot of microorganisms in just human waste. So we don't have to add microorganisms. They're there already. We just want to make the conditions right so they'll grow and use that waste up. As it ends up, the microorganisms that grow in there are just a little bit more dense than the water. So if we can grow the right kind of microorganisms and get them to grow in the right way, then we go to this It says final settling here, but we can go to this secondary settling basin and we can settle out all the microorganisms, and what we're left with is clean treated water at the surface. So the microorganisms settle to the bottom, and in this particular case, this is actually a diagram of what's called an activated sludge process. And so we take a portion of those microorganisms that grow, and you can see coming out of the bottom of that final settling basin, we have a return activated sludge or recycle flow line. So we're going to take those microorganisms that settle out and put them back in to that aeration basin or the biological treatment process so that it'll work faster. Okay, but because we have microorganisms growing in there, every once in a while we're going to have to get rid of some microorganisms, or we just build up a higher and higher and higher concentration, and the process wouldn't work anymore. So we have to get rid of microorganisms, and that's what that sludge line is that comes out of the bottom and goes into that bottom square down there where it says solids treatment. Okay, so now the clean water is going to come off the top, the supernatant, it comes off the top, and it goes to be disinfected in that disinfection box. And there are several ways of disinfecting, and we'll talk about that a little bit later on. In this particular case, it shows a contact basin. Basically what they're doing here is adding some chlorine to disinfect, but that's not real common anymore. Now, you'll notice here that the whole treatment process, what we've done is we're taking an aqueous phase waste and making it into a solid waste. So we're turning that waste into a solid material. Then we separate the solid material from the water and we have clean water. That's the whole idea here. But what that means is we're producing this sludge as a byproduct in the process, and we have to do something with that sludge. And so that's what that solids treatment box down there is. We're going to do something with that solid material that's produced from the waste. So we then have some treated wastewater, and it goes out to the receiving body of water. Maybe it's a lake or a river, or maybe we're going to use that water to irrigate a golf course or something like that. Okay, so that's conventional treatment. You can see again it's divided up into preliminary treatment, primary treatment, secondary treatment, disinfection, and then solids treatment. Okay, so what we're going to do now, and I'm going to start off for a second here talking about, we're going to just follow the water as it flows through the treatment plant. And so we're going to start out at the head end of the plant. Remember we talked about preliminary treatment, or the headworks is what it's often called. And these two figures here show two different ways in which a headworks could be made at a treatment plant. So let's talk about just the components of these pre-treatment systems, and then we'll be done for today. Okay, so you can see in the top one, the raw wastewater comes in and it goes through a flow measuring device called a Parshall flume. You probably know a little bit about Parshall flumes, or flumes of some kind anyway. You can see the shape that you see there is like the plan view shape of a Parshall flume. The idea behind a Parshall flume is the water comes in and the flow is restricted and the slope of the bottom changes a little bit, and then the flow is unrestricted, or in other words it's flared out, and it causes a hydraulic jump. And we measure the height of the hydraulic jump, and the height of that hydraulic jump can then be correlated to the flow rate that's going through the flume. So we're using this flume to measure the flow rate. Usually the levels are measured by some kind of a sonic device, so sound waves are used to measure the height of that jump. But the advantage of these flumes is they don't plug up with stuff. So you could get anything flowing down a wastewater process, and these things are not going to get plugged up by that wastewater, okay, whatever's in the wastewater. So that's why we use flumes in that way. So in the top one then, what happens is the water comes out of the flume, the flow is measured, and it goes into a bar screen. And this is literally just that. It's steel bars that are placed in the water that the flow has to go through, and there might be a half an inch in between the bars, and you just screen out any large material that's found in that wastewater. So it could be rags, could be a bowling ball, could be 2x4s, could be anything. One of the things that's trapped on there real commonly is like plastic feminine hygiene applicators that are not supposed to go in the toilet, but they get down there and they'll get screened out there. But mostly what's on there is rags as it ends up. Lots of different kinds of rags. Okay, so it goes through there and we clean those screens off and throw that stuff away that's on the screens. And then you can see in the top one, it goes into a wet well where the water's lifted up again, and then it goes to this grit chamber we were talking about before. And in the top one, they have what are called vortex grit chambers. There's another kind of grit chamber that's just called an aerated grit chamber, and we'll talk about that. So down at the bottom, it's a very similar thing that has a couple other devices, and we'll talk more specifically about those devices later. Now, next time, what we're going to do is we're going to talk about the individual components in preliminary treatment or in the headworks and how we design those components. So that's what we'll do next. So I think that's it for today. Okay,